I will discuss Mathematics 10, Quarter 1, Week 7, Factoring Polynomials. So our objectives is to recall factoring techniques and to determine the factors of a given polynomial. A polynomial is an algebraic expression that represents a sum of one or more terms containing positive whole number exponents on the variables. Polynomials are classified according to the number of terms. The conventional way of writing a polynomial in one variable is to write the terms in order of descending or decreasing exponents. When a polynomial is written with decreasing exponent, the first term is called the leading term, while its numerical coefficient is called the leading coefficient. The degree of a term that has only one variable is the exponent of that variable. The degree of a term that has more than one variable is the sum of the exponents of that variables. The degree of a polynomial that has only one variable is the highest exponent appearing in any terms, and the degree of a polynomial in more than one variable is the highest sum of the exponents of the variables in any of the terms. Now, is negative 5 a polynomial? If it is a polynomial, what is the degree? So it is a polynomial because it can be expressed as negative 5x raised to 0, therefore its degree is 0. Now let's proceed with factoring. So factoring is the reverse process of multiplication. When a number or polynomial is factored, it is rewritten as a product of two or more factors. A polynomial is factored completely if each of its factors can no longer be expressed as product of two other polynomials of lower degree and the numerical coefficients have no common factor. It is easy to deal with factoring polynomials if we know the products which occur frequently in algebra, which are called special products. Special products are worth remembering because there are special patterns in obtaining them. What are these special products? First, we have a monomial multiplied by a polynomial of two or more terms. So we have a times the quantity x plus y will give us ax plus by. The product is obtained by applying the distributive property of multiplication over addition. Example, 3 times quantity x plus y is equal to 3x plus 3y. The next formula is quantity x minus y times quantity x plus y is equal to x squared minus y squared. The formula states that the product of the sum and difference of two terms is the difference of their squares. Example, quantity x minus 2y times quantity x plus 2y is equal to x squared minus 4y squared. The next formula is quantity x plus and minus y squared is equal to x squared plus and minus 2xy plus y squared. The formula states that the square of the sum or difference of two terms is equal to the sum of the squares plus or minus twice the product of the terms. Example, quantity 2a plus 3b squared is equal to 4a squared plus 12ab plus 9b squared. Example number 2, we have quantity 2a minus 3b squared is equal to 4a squared minus 12ab plus 9b squared. The products are perfect square trinomial. Formula number 4, we have quantity x plus a times quantity x plus b. We will have x squared plus a times x plus b times x plus a times b. So example, quantity x plus 3 times quantity x minus 2 is equal to x squared plus x minus 6. And the fifth formula is here, the numerical coefficient of x is not equal to 1, which are represented by a and c. So we will have quantity ax plus b times the quantity cx plus d will give us a times cx squared plus a times dx plus b times cx plus b times d. So example, quantity 3x minus 4 times quantity 2x plus 5 will give us 6x squared plus 7x minus 20. Formula 4 and 5 suggest that the products are general quadratic trinomials. And formula number 6, we have quantity x plus and minus y times quantity x squared plus or minus xy plus y squared will give us x cubed plus and minus y cubed. Examples, quantity 2x plus y times quantity 4x squared minus 2xy plus y squared will give us 8x cubed plus y cubed. Quantity 2x minus y times quantity 4x squared plus 2xy plus y squared will give us 8x cubed minus y cubed. The formula 6 suggests that the product of a binomial and a trinomial of that form is a sum or difference of two cubes. Now, the first factoring method is the common monomial factor. So first, find the greatest common factor of the terms in the polynomial. This is our first factor. Now, how do we get the GCF? Suppose we're going to get the GCF of 14x squared, y squared, 18xy, and 2x cubed, y cubed. We will express each as a product of prime factors. So 14x squared plus y squared is equal to 2 times 7 times x times x times y times y. 18xy is equal to 2 times 3 times 3 times x times y. And 2x cubed y cubed is equal to 2 times x times x times x times y times y times y. Then determine their common prime factors. These are 2, x, and y. So the GCF is 2xy. The degree of the GCF is less than or equal to the degree of the expression with the lowest degree. Then after getting the GCF, we will divide each term of the polynomial by the GCF to get the other factor. So let's have example number 1. So factor 12a cubed plus 36ab minus 24a squared b squared. The GCF is 12a, and dividing 12a cubed, 36ab, and negative 24a squared b squared by the GCF, we will get a squared plus 3b minus 2ab squared. Now we can rewrite the trinomial a squared plus 3b minus 2ab squared as a descending power of a. So we will have 12a times the quantity a squared minus 2ab squared plus 3b. Let's have another example. Suppose we are going to factor 15x squared y cubed plus 12x cubed y squared minus 27x cubed y cubed. We get the GCF, and our GCF is 3x squared y squared. Dividing 15x squared y cubed, 12x cubed y squared, and negative 27x cubed y cubed, we will get 5y plus 4x minus 9xy. So the factors are 3x squared y squared and 5y plus 4x minus 9xy. Then we have the next factoring method, which is factoring difference of two squares. In formula number 2, the formula states that the product of the sum and difference of two terms is the difference of these squares. So if we multiply quantity x minus y times the quantity x plus y, will give us x squared minus y squared. So that is difference of two squares. So it's easy to deal with factoring of difference of two squares if we know sum of the perfect squares. So these are numbers highlighted by yellow, which are squares of numbers 1 to 15. So what are the steps in factoring the difference of two squares? Number 1, get the principal square root of each of the two squares. Using these square roots, form two factors, one is sum and the other is difference. Let's have example number 1. So factor 9a square minus 49b square. So get the square root of each term. Square root of 9a square is equal to 3a. Then square root of 49b square is equal to 7b. Using 3a and 7b, form the sum. So that is quantity 3a plus 3b and the difference, which is quantity 3a minus 7b. So therefore, 9a square minus 49b square is equal to the product of 3a plus 7b and 3a minus 7b. Let's have example number 2. So factor 12a cubed minus 27ab square. So this is not a difference of two squares. Remember that in factoring polynomials, we must first look if the polynomial can be factored using the common monomial factoring. Now, on this case, 12a cubed and negative 27ab square has common monomial factor, and that is 3a. Now, dividing 12a cubed and negative 27ab square will give us 4a square minus 9b square. Now 4a square minus 9b square is now a difference of two square. So we will factor 4a square minus 9b square using the steps on factoring difference of two square. So we get the square root of 4a square, and that is 2a. We get the square root of 9b square, and that is 3b. So therefore, the factor of 4a square minus 9b square are 2a plus 3b and 2a minus 3b. So 12a cubed minus 27ab square is equal to 3a times the quantity 2a plus 3b times the quantity 2a minus 3b. Let's have factoring the sum and difference of two cubes. Formula 6 states that quantity x plus and minus y times the quantity x squared plus and minus xy plus y squared will give us x cubed plus and minus y cubed. Formula 6 suggests that the product of a binomial and a trinomial of that form is the sum or difference of two cubes. So what are the steps in factoring the sum and difference of two cubes? First, get the cube root of each perfect cube. Using the operation between the cubes, obtain a binomial factor using the cube root in step 1. Form the second factor as follows. Square the first cube root, multiply the two, square the second cube root. For the sum of two cubes, the terms of the trinomial factor have alternating signs. For the difference of two cubes, the terms of the trinomial factor are all positive. So let's have example factor 8y cubed plus 27. Get the cube root of each perfect cube. So we get the cube root of 8y cubed, that is equal to 2y, and the cube root of 27 is equal to 3. So 8y cubed plus 27 is equal to quantity 2y plus 3. So that will be our first factor. For the sum of two cubes, the terms of the trinomial factor have alternating signs. So that will be the sign of our second factor, which is a trinomial. Square the first cube root, so we will square 2y, so that will give us 4y squared. So that will be the first term of our trinomial factor. Multiply the 2, so we will multiply 2y and 3, that will give us 6y. So that will be the middle term of our trinomial factor. And square the second cube root, so we will square 3, that will give us 9. That will be the last term of our trinomial factor. So therefore, 8y cubed plus 27 is equal to the quantity 2y plus 3 times the quantity 4y squared minus 6y plus 9. So let's have the second example. So factor 64x cubed minus 125. Get the cube root of each perfect cube. So cube root of 64x cubed is 4x, and the cube root of 125 is equal to 5. So 64x cubed minus 125, so is equal to quantity 4x minus 5. That will be our first factor. For the difference of two cubes, the terms of the trinomial are all positive. So that will be the sign of our trinomial factor. So square the first cube root, so we will square 4x, that will give us 16x cubed, x squared rather. So that will be the first term of our trinomial factor. Then multiply the 2, multiply 4x and 5 will give us 20x. So that will be the middle term of the trinomial factor. And square the second cube root, which is 5 squared, so that will give us 25. That will be the last term of our trinomial factor. So therefore, 64x cubed minus 125 is equal to the quantity 4x minus 5 times the quantity 16x squared plus 20x plus 125. Now let's have factoring perfect square trinomial. In formula number 3, quantity x plus and minus y squared is equal to x squared plus and minus 2xy plus y squared. The formula states that the square of the sum or difference of two terms is equal to the sum of their squares plus and minus twice the product of the terms. The product is a perfect square trinomial. Recall that the square of a binomial results in a perfect square trinomial. So let's have a quantity x minus y squared will give us x squared minus 2xy plus y squared. If we square x plus y, will give us x squared plus 2xy plus y squared. So how do we know whether a trinomial is a perfect square trinomial? Let's take x squared plus 2xy plus y squared as an example. The first term is a perfect square. So x squared is a perfect square. The last term is a perfect square. Y squared is a perfect square. The middle term is twice the product of the square root of the first and last term. So the square root of x squared is x. the square root of y squared is y, and twice the product of x and y is 2xy. So it satisfies the three conditions, so we can say that x squared plus 2xy plus y squared is a perfect square trinomial. So how do we factor perfect square trinomial? Get the principal square root of the first and the last term. So when we say principal square roots, these are positive square roots of a number or an algebraic term. Use the sign of the middle term between these roots and square the binomial obtained in step 1. So let's have an example. Factor y squared plus 8y plus 16. So get the principal square root of the first and last term. So square root of y squared is equal to y. Square root of 16 is equal to 4. Again, I will emphasize we only need the positive square root or the principal square root. So y squared plus 18 plus 8y plus 16 is equal to the binomial factor whose first term is y and the second term is 4. So how do we determine the operation between the two terms of the binomial factor? Use the sign of the middle term between these roots. Now since the sign of our middle term is positive or addition, so we will write positive between the terms of our binomial factor. Then square the binomial obtained in step 2. So therefore, y squared plus 8y plus 16 is equal to quantity y plus 4 square or y plus 4 times the quantity y plus 4. Let's have the second example. So factor 4x squared minus 6xy plus 9y squared. Get the principal square root of the first and the last term. So we get the square root of 4x squared, which is 2x, and we get the principal square root of 9y squared, which is 3y. So therefore, 4x squared minus 6xy plus 9y squared is equal to the binomial 2x and 3y. So that will be the terms of our binomial factor. Now since the sign of the middle term is negative or subtraction, so we will use subtraction as the sign between the two terms of our binomial factor 2x and 3y. Then square the binomial obtained in step 2. So that will give us 4x squared minus 6xy plus 9y squared is equal to quantity 2x minus 3y squared. The next factoring method is factoring quadratic trinomials. A quadratic trinomial is a second-degree polynomial with three terms. This is in the form ax squared plus bx plus c, where a, b, and c are non-zero integral coefficients. That means a, b, and c are not equal to 0. Let's have example of a quadratic trinomial. So we have x squared plus x minus 2. So the value of a is 1, the value of b is 1, and the value of c is negative 2. The other example, we have 3x squared plus 7x plus 2. The value of a is 3, b is equal to 7, and c is equal to 2. In x squared plus x, if an algebraic term has no numerical coefficient, then it is understood that it is equal to 1. So we do not write 1x squared or 1x. So let's have factoring a quadratic trinomial of the form ax squared plus bx plus c, where the value of a is equal to 1. But not all quadratic trinomials are factorable or can be factored. We use the discriminant b squared minus 4ac to determine if a quadratic trinomial is factorable. If b squared minus 4ac is greater than 0 and a perfect square, then the trinomial is factorable. So let's have example x squared plus x minus 2. So the value of a is 1, the value of b is 1, and the value of c is negative 2. So let's check whether x squared plus x minus 2 can be factored. So substitute the value of a, b, and c to the discriminant b squared minus 4ac. So that will give us 1 squared minus 4 times 1 times negative 2. And that is equal to 1 minus negative 8. And that will be 1 plus 8, and that is equal to 9. So 9 is a perfect square, therefore x squared plus x minus 2 is factorable. So let's review first the absolute value. So absolute value is the distance of a number from 0 on a number line. Since it is distance, it is always positive. Examples are absolute value of negative 5 is 5, absolute value of negative 7 is 7, then absolute value of positive 7 is 7. So to add integers with the same sign, add their absolute values and copy the common sign. So example, negative 4 plus negative 8 is equal to negative 7. So the absolute value of negative 4 is positive 4. The absolute value of negative 8 is positive 8. So add their absolute values. So 4 plus 8 will give us 12. Then copy the common sign, which is negative. So therefore, negative 4 plus negative 8 is equal to negative 12. Now to add integers with different sign, subtract their absolute value and copy the sign with greater absolute value. Example, negative 9 plus positive 3 is equal to negative 6. The absolute value of negative 9 is positive 9, and the absolute value of positive 3 is positive 3. Subtract their absolute values, so we will subtract 9 and minus 3, so that will give us 6. Copy the sign of the number with greater absolute value. So negative 9 has greater absolute value, so we will copy the negative sign. So therefore, negative 9 plus positive 3 is equal to negative 6. So we follow these steps in factoring trinomials of the form ax squared plus bx plus c, where a is equal to 1. Find two factors of c whose sum equals the coefficient b. Using the form quantity x plus blank and quantity x plus blank, fill this up with two factors found in step 1. So let's have example number 1. Factor x squared minus 4x minus 12. Find two factors of c whose sum equals the coefficient b. So our c is negative 12, so we will get the factors of negative 12. So these are 1 and negative 12, negative 1 and positive 12, 2 and negative 6, negative 2 and positive 6, 3 and negative 4, negative 3 and positive 4. Then we get the sum of the factors. So 1 and negative 12 is equal to negative 11, negative 1 and 2 is 11, 2 and negative 6 is negative 4, negative 2 and positive 6 is positive 4, 3 and negative 4 is negative 1, negative 3 and positive 4 is positive 1. Now from the factors of negative 12, we see that 2 and negative 6 has the sum of negative 4, which is equal to the value of b. So we'll take 2 and negative 6 as the constant of our binomial factors. So therefore, x squared minus 4x minus 12 is equal to the quantity x plus 2 times the quantity x minus 6. Let's have the second example. Factor x cubed minus 5xy plus 6xy squared. Now remember, in factoring polynomials, we must first look whether the polynomial can be factored using the common monomial factoring. So here, it is not a quadratic trinomial because the degree of the polynomial is 3. And based on our observation, there is a common monomial factor in the polynomial. So factor by common monomial factoring will give us x times the quantity x squared minus 5y plus 6y squared. Now we can factor x squared minus 5y plus 6y squared. So the factor of 6 are 1 and 6, negative 1 and negative 6, 2 and 3, negative 2 and negative 3. The sum of the factors are 1 and 6 is 7, negative 1 and negative 6 is negative 7, 2 and 3 is positive 5, negative 2 and negative 3 is negative 5. So from the factors of positive 6, we can say that negative 2 and negative 3 has the sum of negative 5, which is equal to the value of b. So we take negative 2 and negative 5 as the constant of our binomial factors. So therefore, x squared minus 5y plus 6y squared is equal to quantity x minus 2y times the quantity x minus 3y. And x cubed minus 5xy plus 6xy squared is equal to x times the quantity x minus 2y times the quantity x minus 3y. Now how about factoring a quadratic trinomial of the form ax squared plus bx plus c where the value of a is not equal to 1. So we will not use the conventional method of getting the factor of this quadratic trinomial where the value of a is not equal to 1. So we will use this technique in factoring 5x squared minus 7x minus 6. So here, the value of a is 5, b is negative 7, c is negative 6. So multiply a by c. So that will give us x squared minus 7x minus 30. Factor x squared minus 7x minus 30 where a is equal to 1. Now, so it is easier to factor. And the factors are x minus 10 and x plus 3. Now, since a is equal to 5, we will divide both second terms of the binomial by a. So that will give us quantity x minus 10 divided by 5 times the quantity x plus 3 divided by 5. Then reduce fraction to lowest terms if possible or necessary. Then we will have quantity x minus 2 times the quantity x plus 3 over 5. So cross multiply to eliminate the denominator. So we will multiply 5 by x. So that will give us quantity x minus 2 times quantity 5x plus 3. Therefore, 5x squared minus 7x minus 6 is equal to quantity x minus 2 times quantity 5x plus 3. Let's have example number 2. So factor 3a squared minus 10ab minus 8b squared. So this time we will use another technique or method. So we have 9 boxes. We have 3 rows and 3 columns. We write 3a squared on this box. We write negative 10ab on the first row, second column. Then we multiply 3a squared and negative 8b squared. So that will give us negative 24a squared b squared. Then factor 3a squared. So we will have 3a and a. Then we take factor of negative 24a squared b squared such that if we add will give us negative 10ab. And that is negative 12ab and positive 2ab. Then divide 12ab by 3a, that will give us negative 4b. Divide 2ab by a, that will give us 2b. So the factors are 3a plus 2b and a minus 4b. So that means 3a squared minus 10ab minus 8b squared is equal to the quantity 3a plus 2b times the quantity a minus 4b. Let's have example number 3, factor 2x to the 6 plus 3x cubed minus 5. So this time we are not dealing with a quadratic trinomial because the degree of the polynomial is of the 6th degree. But some polynomials can be factored using the concept of factoring a quadratic trinomial. Now we can represent x cubed as equal to u. So therefore, x to the 6 is equal to u squared. Then we have 2x to the 6 plus 3x cubed minus 5. So will give us, by substitution, 2u squared plus 3u minus 5. We can now apply factoring quadratic trinomial. So we factor, we multiply 2 by negative 5, that will give us negative 10. So that will become u squared plus 3u minus 10. And after factoring, we will arrive with quantity u plus 5, quantity u minus 2. Now since our a is 2, divide both second terms of the binomial by a. So that will give us quantity u plus 5 over 2 times quantity u minus 2 divided by 2. Then after dividing and by cross multiplying, we will have quantity 2u plus 5 times quantity u minus 1. Now since we represent u, we represent x cubed as u, we will now substitute. So we will have quantity 2x cubed plus 5 times the quantity x cubed minus 1. Now x cubed minus 1 is difference of 2 cubes. So we can factor this. So the factors are quantity x minus 1 times quantity x squared plus x plus 1 times the quantity 2x cubed plus 5. Therefore, 2x to the 6 plus 3x cubed minus 5 is equal to the quantity 2x cubed plus 5 times the quantity x minus 1 times the quantity x squared plus x plus 1. And the last factoring method is by factoring by grouping. So factoring by grouping can be extended to expressions containing 4 or more terms. So group terms that have a common monomial factor, factor out the common monomial factor from each group. There will be usually 2 groups and sometimes the terms must be arranged. Factor out the remaining binomial factor if there exists. So let's have example. Factor 9x squared minus y squared plus 4y minus 4 completely. Now we will group negative y squared plus 4y minus 4, then multiply all by negative 1 to make the first term negative y squared positive. So that will give us 9x squared minus 1 times the quantity y squared minus 4y plus 4. And that will give us, removing 1, because it is understood that there is 1 after the minus sign. So we will have 9x squared minus quantity y squared minus 4y plus 4. Now y squared minus 4y plus 4 is a perfect square trinomial. So we can factor this, and the factor of that is the square of the binomial y minus 2. So we will have 9x squared minus quantity y minus 2 squared. So these are difference of 2 squares. So 9x squared and quantity y minus 2 squared are both perfect squares. So we can apply factoring difference of 2 squares. So we get the square root of 9x squared, so that is 3x, and we get the square root of quantity y minus 2 squared, and that is y minus 2. Again, we only need the principal square root or the positive square root. So the factors are quantity 3x plus quantity y minus 2 and quantity 3x minus quantity y minus 2. Then removing the brackets and replacing it by parentheses, we will have quantity 3x plus y minus 2 times the quantity 3x minus y plus 2. So therefore, 9x squared minus y squared plus 4y minus 4 is equal to the quantity 3x plus y minus 2 times the quantity 3x minus y plus 2. Now let's check whether our factors are correct. So if you find it difficult to multiply a polynomial by another polynomial, you can use this method. So we write the 2 factors, then multiply 3x and 3x, so that will give us 9x squared, multiply 3x and y, that is 3xy, multiply 3x and negative 2, that is negative 6x, multiply 3x and negative y, that will give us negative 3xy, multiply y and negative y, that is negative y squared, multiply negative 2 and negative y, that is positive 2y, multiply 3x and 2, that will give us 6x, y and positive 2, that is 2y, and negative 2 times positive 2, that is negative 4. Then add all the products. We will not include this because their sum is equal to 0. So 9x squared is minus y squared plus 2y plus 2y minus 4. And that will give us 9x squared minus y squared plus 4y minus 4. So therefore, our factor is correct. So that ends my discussion. So special thanks to the following: Sir Resti Rodelas, Ma'am Corazon Arrihino, Sir Roderick Arminjola, and our principal, Sir Joseph B. Alegre, Principal of the Ilaya Barangay Integrated School, to Ma'am Erlinda C. Lapada, Math Coordinator, Ilaya Barangay Integrated School, to the Math Department and ESP Department of Ilaya Barangay Integrated School, and to all my students at Ilaya Barangay Integrated School. To God be the glory and thank you.